want certain kind of stability in our lives. Similar to the human beings, atoms also require some kind of stability. And the atom would be stable if it attains a certain kind of electronic configuration of its shells. Recall the Bohr-Bury rule which we have learned, which says that for the first shell, that is K shell, the maximum number of electrons can be 2. For the L shell, the maximum number of electrons can be 8. For the M shell, the maximum number of electrons can also be 8. So similarly, for each and every shell, there is a certain number, there is certain maximum limit up to which the electrons can be accommodated. After that, electron will go in another shell. So this is what we have studied in our previous sections. But if we see about the second period, then let me show you that how the electronic configurations are there and what will the atom do to attain the stability. So this is our second period of the periodic table. Lithium, beryllium, then there is a D block, but I will write the another elements over here. Boron, carbon, nitrogen, oxygen, fluorine and neon. So let me write the atomic numbers of them. That is, this is 3, 4, 5, 6, 7, 8, 9, 10. And what will be their electronic configurations? This is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and 2, 8. Now seeing this line, we can easily determine that this 2, 8 is the most stable because it is following that maximum limit, right? In the first shell, the maximum number of electrons are 2. In the second shell, the maximum number of electrons are 8. So it is stable. So it is stable, it is happy in its place. But if I talk about this 2, 1, what is there? In the first shell, the number of electrons, the maximum limit is already there. So in the first shell, there is no problem. But what about this one? It should be 8, but it is not 8. So what can this atom do to achieve its stability? It can either gain 7 electrons or it can lose 1 electron. So gaining and losing electrons are not that easy what it seems to be in the board. Actually, there is a requirement of lot of energy expenditure to gain or lose electrons. That is why it will lose 1 electron preferably than gaining 7 electrons. So what it will do? It will lose 1 electron. So this is permissible. Similarly here, it will not gain 6 electrons, it will lose 2 electrons because it would want that the less energy expenditure should be there. Similarly, it will lose 3 electrons. What will happen over here? Gaining 4 electrons or losing 4 electrons is not an easy task. That is why it will share 4 electrons. It will share 4 electrons. And in this case, they were losing electrons. Now over here, losing 5 electrons is difficult than gaining 3 electrons. Therefore, nitrogen will gain 3 electrons. To achieve 2, 8 configuration, it will gain 2 electrons. It will gain 1 electron. And since this atom is so much stable, it does not require to lose, share or gain electrons. It is already happy in its place. So what we have seen that atoms can lose, gain or share electrons in order to attain stability. So the requirement of losing, gaining or sharing electrons is different for each atom. So what do we call this in our chemistry? We call this term as valency. What is valency? Valency is basically the number of electrons which can be shared the number of electrons which can be shared, lost or gained in order to attain stability. In order to attain stability. So this is what our valency is. Valency is the number of electrons which can be shared, lost or gained in order to attain stability. Don't confuse the word valency with valence electrons, because what are the valence electrons? Valence electrons are the electrons which are present in the outermost shell of an atom. And valency represents the need of the electrons which is basically there present in an atom to attain the stability of the atom. So I hope you have understood the concept of valency from here. Thank you so much.